Lesson 1 of functions. So we're going to talk about maps of functions. We're going to talk about being able to describe functions as one-to-one, two-to-one, many-to-one, flow diagrams of functions, also domain and range. So we'll also see these words, domain and range. These are very important. Okay, so functions as a mapping. Consider the equation y equals 2x plus 3. It describes the relationship between two variables x and y. In this case, 3 is added to twice the value of x to produce y. So 3 is added to twice the value of x, and that equals y. A function is a particular type of a relationship between two variables. It has certain characteristics. So if we consider the equation y equals 2x plus 3, and we know from our days of graphing, this would look something like this, just a straight line. Okay, for values of x within -1, okay, so where -1 is less than or equal to x, which is less than or equal to 3. Okay, so between -1 and 3, including -1 and 3, we can make a table. So if we made a table of those values and we plug them in, okay, we would end up with these y's. So 0 times 2 plus 3 is 3, and so on. And we can see, if I take these tables and I put them in these two ovals, and I map them with these arrows, okay, this is a mapping. So this is the same data as this table, except it's in a function map. Okay, and these function maps can be very useful in certain cases. So let's take a look here. With a function, each value in set B, the range, okay, is produced from one value in set A, the domain. The relationship can be written as, we see this f bracket bracket x, we say that as f of x. F of x equals 2x plus 3, okay, where that x is between -1 and -3. Or we say this, okay, f, the function of x maps to 2x plus 3 between -1 and 3. Now I want to notice between our domain and range, our b value, okay, is the same as our range, which is the same as our y. So range is going to be your y values, and domain is your x values. Okay, they just have special names when we're talking about functions. Okay, it is usual to include the domain after the function, as a different domain will produce a different range. Meaning, if we did -1 to 4 here instead, okay, well our range would be, okay, we go up to 11 then. Now, if we take a different function, okay, well we can map 1 to 1 like we are here. Each x has one y. Well, we can also have a many to 1. If I take a look here, it gets a bit confusing, but I can notice at 9, all right, and 4, and 1, that I have two arrows going back to them. Okay, well, what's important here is each x only has the one y. Now, y can have many x's. Each part in our answer can have many beginning parts, but these can only go to 1. Okay, so this is a many to 1, and this would be a 1 to 1. The function above, f of x, 2x plus 3, between -1 and 3, is a 1-to-1 function, as one value in the domain maps onto one value in the range. However, the function f of x, x squared, where x includes a set of integers, okay, right here, is a many to 1 function, as a value in the range can be generated by more than one value in the domain as shown, like -3 and 3 both go to 9. It is important to understand that one value in the domain, set A, maps to only one value in the range, set B. Therefore, the mapping is shown as a function as f of x equals x squared, where x is an integer. Okay? Some mappings will not represent functions. For example, consider the relationship y equals plus or minus the square root of x. So if I take a look here, square root of 1, square root of 4, square root of 9, square root of 16, well, we know if I take a square root, I get two answers. I get a positive answer, okay, or principal square root, and I get a negative answer. Okay, so because this is, we start with a value and it goes to two things, this is not a function. So each x can only have one y. Y's can have many x's. Okay, so each x can only have one y. Y's can have many x's. If you're going to write one thing down from this whole thing, this is what you need to write down, because this determines if it's a function or not. Now, I don't suggest you only write this down. I would write much more down. Okay, so let's take a look here. If A and B are non-empty sets, then a mapping from A to B is a rule which associates the element of B from every element of A. Here are two types of mapping. We have type 1, 1 to 1. Okay, 1 maps to 5, 2 to 11, 3 to 8, sure. Okay, what it ends up in is not so important for our purposes right now. Okay, type 2, we have negative 2 goes to 4, and 2 goes to 4. Negative 1 and 1 both go to 1. Well, we have our y's, they have two x's, that's okay, because each x only has one y. If we had something like negative 2 also goes to 3, well, now we have a problem. That would not be a function. Now we use an arrow with a tail, so like this symbol right here, okay, to avoid confusion of x, this means something else right here, which means x tends towards, so that's something else. This is, we'd say, x maps to x squared. That's how you'd say that. A function is a mapping which associates one and only one element of B with every element of A, like we've been talking. So a function is a one-to-one mapping or a many-to-one mapping. The notations used are either f of x or f the function x maps to. The graph of y equals 2x plus 1 is a one-to-one mapping. Each x only has 1. The graph of y equals 1 over x is a one-to-one mapping. Okay, these lines would never actually touch, so they don't overlap, so that's okay. Okay, the graph of y equals sine of x is a one-to-one mapping. Now, this graph here, we can assume all our graphs keep going forever. So if I continue this graph, it would make this, and we can see that this x value here, its y's value is only ever there. However, if I looked here, okay, I have a different x, but I have the same y. Well, that's okay. Okay, remember, x's can only have one y, but y's can have many x's. And again, the domain of a function is the set of all the points on which the function acts. Meaning, okay, how it goes. The range of a function is the set of all the points which the function maps. Okay, so if I put in something, that's domain. Okay, if what I get out is my range. Okay, important to note, we do need the notation sometimes with functions. So just to see this again, remember the z is our integers. The z with a plus, we might not have seen that before, is just our positive integers. Okay, natural numbers from 0 and up. Okay, rational numbers can be written as a fraction, and our real numbers. Okay, if a domain is not specified, then it's assumed all real values. Okay, if you don't get a domain, it assumes it's everything. Okay, let's just do a little function practice here before we go on. You can pause it and try this. So if f of x is 3x minus 1, g of x is 1 minus x squared, and h of x, where x maps to 10 over x. Okay, let's just plug in a couple of these. Let's do a, d, and c. Okay. So with a, we put a 2 in for here, so we do 3 times 2 minus 1. 6 minus 1 is 5. f of 2 equals 5. For g, we do 1 minus 3 squared. So 1 minus 9, we get negative 8. For h, we do 10 over 2, so we'll get 5. Okay? Now, take a look at e here. E, if f of x equals 1. If f of x equals 1, then 3x minus 1 equals 1. So they're saying if I take this and I substitute that in for my whole function, I would have 1 equals 3x minus 1. And then we could solve from here, plus 2. Plus 1 gives me 2 equals 3x divided by 3. We get 2/3 equals x. Alright, so calculating the domain from the range. The domain is the set of input values and the range is a set of output values for a function. Note that the range is not the difference between the greatest and least as in statistics. So remember, if you find like mean, median, mode, and range, that means something different. Okay, our range here is just how much, okay, it's not our difference between like this top point and this bottom point. Okay, it's the values that our y can eventually reach. Okay, both positive and negative. Okay, as high as it goes and as low as it goes. So if I have a function here, x cubed minus 3x, where between negative 2 and 3, so between negative 2 and 3, okay, so I only care about this function between this point and this point. Okay, if it keeps going, well, we don't care about that right now. Okay, so what is our range? Well, our ranges are between our highest and our lowest points. How far is it? Well, it goes from negative 2 to 18. Okay, from negative 2 to 18, so our range is written as negative 2 of f of x between 18. Okay, so let's do a different one. So we have our same one, same function, x cubed minus 3x, where x is all real numbers. Okay, so we're not limited by this domain anymore. Our domain is all real numbers. So actually these lines, we don't need them anymore. Well, what do we think is going to happen with this graph? It's going to continue up, and it's not going to go very fast over, but eventually it is going to go everywhere over here, and this one's going to go everywhere over here, and we've already covered in between them. So our range is also going to be all real numbers, because eventually I'll cover every number to the right, or I'll cover every number to the left. So our range of f of x is the set of all real numbers. Okay, just the last couple of questions here. Which of these show a function? Okay, I have this dot, it goes to one dot, this dot goes to one dot. Okay, this dot goes to this dot, that's okay. Alright, yes. Alright, pause it, try as much of these as you feel comfortable, and then come back. Okay, B, we have one-to-one function, awesome. Okay, C, okay, here to here, here to here, here to here, none of these parts of our domain go to any two parts of our range, good. Okay, I look here immediately and I go to 2, that is not a function. Ah, look, A, B, C are functions, cool. Alright, give the domain and range for each of these. So our domain is here. That's it. Our domain is done. Now for our range, we need to plug in our bottom value and our top value. So if I do 2 times -1 minus 1, so 2 times -1 is -2 minus 1 equals -3. Okay, and if I plug in a 3, I get 2 times 3 minus 1 is 6, minus 1 is 5. So our range of f of x equals 3, -3, f of x between 5. Let's check how we did. Awesome. Okay. I'm not gonna go through and do all of these. All right, but you can check your work here. Okay. Last thing here, flow diagrams. These are quick and easy. Okay. These are just writing out our order of operations. So if we have the function f of x equals 3x minus 1, okay, we can create a flow diagram by just writing out our steps. So my order of operations, I take x, I multiply by 3, that gives me 3x, and I subtract 1, and that gives me 3x minus 1. So it's that simple. Okay, there's no tricks to it. Just go through how you should do it. When you're ready, we'll come back and we'll go over the answers. Alright, so if I have x, okay, my first thing here is I'm going to multiply by 2. Okay, once I multiply by 2, I need to add 5. And once I've added 5, I have this squared here, and I square it, and I get 2x plus 5. Okay, g, maybe a little bit more complicated. First, I need to multiply by -7x, or -7. Then I need, how do we say this? Interesting. Yeah, I add 5, because if I had -7, it just matters how it's written. -7, and this is a positive 5. This equals the same thing, okay? So just be careful with that. And once I've done that, I divide by 3, and we're done. Okay, and that's function mapping. Or that's flow diagrams at the end of our function mapping.